Vitamin K is an essential nutrient for blood clotting and bone formation. The ingested vitamin K is reduced by vitamin K oxidorreductase (VKOR) and becomes a coenzyme that activates vitamin K-dependent protein (VKDP), which exerts various physiological effects. Warfarin is administered to patients who have suffered a thromboembolic event such as stroke, but the bleeding tendency varies among individuals. For this reason, blood samples are taken periodically as a test to set the exact dosage for each individual patient. But long-term testing is a heavy burden for patients. In this study, we attempt to determine the amount of vitamin K is in the body to antagonize warfarin in a non-invasive manner using urine. It has been shown that dietary vitamin K1 (PK) is excreted in urine as a conjugate of vitamin K3 (MD), a metabolic intermediate. However, the detailed disposition of MD in the body is not clear. In this study, we aimed to establish a comprehensive method for determination of unconjugated and conjugated MD. First, unconjugated MD derivatized by Ca was measured by NMR, and the signals of naphthoquinone ring and Ca were detected. Ca is bound to the 3 position of naphthoquinone ring. The MDCA was measured by UPLC ESI MS-MS. The detection sensitivity of MD was greatly improved after derivatization, and the lower limit of quantification was less than 1 nanogram per milliliter. In addition, free MD was not detected after 16 minutes of derivatization, indicating that Ca has a high derivatization efficiency for MD. These results indicated that the derivatization method enables precise quantification of unconjugated MD. Next, unconjugated MD in urine from mice was measured. 8-week-old mice were used for experiments and treated with MD or PK at 10 micromole per kilogram for 5 days. Plasma was obtained by slaughter 3 hours after administration. Mice were kept in metabolic cages, and urine was collected. Plasma vitamin K concentration were measured, and it was confirmed that the administered MD and PK were transferred into the blood. The amount of urinary unconjugated MD excretion after oral intake of PK increased than basal MD excretion. Last, as a standard product of the unconjugated MD in the body, the MD glutathione and MD N-acetylcysteine were synthesized organically, and the structure was determined by NMR. In this study, first quantification method of vitamin K precursor MD was established. Next, we found that urinary unconjugated MD derivatized from PK is increased than basal MD excretion after oral administration of PK in mice. Last, conjugated MD standard was synthesized chemically. In the future, comprehensive quantitative analysis of conjugated MD in biological samples will contribute to new understanding of the mechanism of vitamin K conjugation metabolism by clarifying the disposition of MD from conjugation to the excretion. In addition, if the relationship between the disposition of MD and the amount of vitamin K in the body is classified, it is expected that a new test method that can strictly measure the amount of vitamin K in the body non-invasively without blood sample will be applied to clinical practice.